Numerical number 1. The charge is distributed along x-axis and the linear charge distribution lambda is given by 4x plus 5 microcoulomb per centimeter. What is the charge present from x1 equal to 2 centimeters to x2 equal to 3 centimeters along this distribution? We have got charge present along x-axis and the linear charge density lambda is given by 4x plus 5 microcoulomb per centimeter. We want to find out the charge present in between x1 equal to 2 centimeters and x2 equal to 3 centimeters. 4x plus 5 microcoulomb per centimeter. Lambda is charge present per unit length. Length in this case will take dx because the charge is distributed along x-axis. dq we will be getting 4x plus 5 dx. This is the required equation which we will integrate to get the total charge. Q, the total charge, will be integration of 4x plus 5 dx from 2 to 3. We can integrate this term 1 by 1, 4x dx plus integration of 5 dx. The limits are from 2 to 3. Q is equal to integration of 4x dx plus integration of 5 dx. The limits are from 2 to 3. Here we can take 4 outside, integration of x dx. Here we can take 5 outside, integration of dx. The limits are from 2 to 3. Integration of x dx is x square upon 2 from 2 to 3 plus 5. Integration of dx is x from 2 to 3. Here 2 can be taken outside. X square means 3 square minus 2 square plus 5. We can replace x by 3 minus x by 2. 4 upon 2 will be getting 2. 9 minus 4 plus 5. 3 minus 2 means 1. 2 into 9 minus 4 is 5 plus 5. And the charge which we will be getting, it will be 2 into 5 plus 5. It will be 10 plus 5. Q will be 15 microcoulomb. Along this charge distribution, the charge present from x1 equal to 2 centimeters to x2 equal to 3 centimeters is 15 microcoulomb. Second numerical. How many electrons should be removed from a given body to give it a positive charge of 10 picocoulombs? We have done earlier that in order to give a body a positive charge, electrons are to be removed from that body. How many electrons are to be removed to give this body a positive charge of 10 picocoulomb? We can take up the concept of quantization of charge, which states that Q is equal to N into E. Q is the amount of charge which is to be given to that body. E is a charge on one electron. The charge which is given to the body is 10 picocoulomb. So this Q is 10 picocoulombs. 10 into 10 to the power of minus 12 coulombs. N is the number of electrons which are to be removed from the body, and E, the electronic charge, is 1.6 into 10 to the power of minus 19 coulomb. Here we want to find out the value for N, the number of electrons which are to be removed. N by cross multiplication will become Q upon E. Q is 10 into 10 to the power of minus 12 upon E is 1.6 into 10 to the power of minus 19 coulombs. Here if you solve it, it will be 10 upon 1.6 into 10 to the power of minus 12 plus 19 electrons. These are the number of electrons which are to be removed from the body. It will be 10 into 10 upon 16 into 10 to the power of 7, 8, it will be 5, 4, it will be 5. We will be getting 25 upon 4 in 10 to the power of 7 electrons. 25 upon 4, if you solve it, it will be 6.25 into 10 to the power of 7 electrons. That means 6.25 into 10 to the power of 7 electrons are to be removed from that body in order to give that body a positive charge of 10 picocoulombs. Numerical number 3. A charge of plus 22 microcoulomb is given to 3 conducting spherical bodies A, B and C of radius 2 cm, 4 cm and 5 cm respectively are placed in electrical contact. Then what is the charge acquired by each spherical body? When 3 bodies A, B and C are placed in electrical contact, then all the 3 bodies will acquire same potential. That means electrostatic potential is same. The electrostatic potential will remain constant. When electrostatic potential will remain constant will be same in all the 3 spheres. The sphere which is big in size will acquire more charge and the sphere which is small in size will acquire less charge. Let the 3 spheres be A, B and C as is given in the numerical. A has got a radius of 2 cm which is smallest among the 3. B has a radius of 4 cm and C is largest among the 3, has got a radius of 5 cm. Let the charge acquired by A be QA, the charge acquired by B be QB and the charge acquired by C be QC, so that the sum of the 3 charges is plus 22 microcoulomb. That means QA plus QB plus QC will be 22 microcoulomb. Now since electrostatic potential remains same, the charge acquired by each body will be depending upon the size, will be depending upon the radius. More the radius, more will be the charge, less the radius, less will be the charge. It means that the 3 charges which are to be given to the 3 spheres will be in the ratio of their radius. QA is to QB is to QC, they'll have the same ratio as the radius. RA is to RB is to RC. The radius of A is 2 cm, the radius of B is 4 cm, the radius of C is 5 cm. That means the charges which are to be distributed will be in the ratio of 2:4:5. Since the 3 charges QA is to QB is to QC are in the ratio of 2:4:5, it means that we can assume that let QA be equal to 2x, QB equal to 4x, QC equal to 5x. Here we can assume that x is any constant term. Since all the 3 charges is 22 microcoulomb, QA plus QB plus QC is 22 microcoulomb. QA is 2x, QB is 4x, QC is 5x, is 22 microcoulomb. Now 5 plus 4, 9, 10, 11x will be 22 microcoulomb. X will become 22 on 11 microcoulomb. X will be getting 2 microcoulomb. Since X is 2 microcoulomb, we can have the value for 3 charges. QA is equal to 2x. It will be 2 into 2 microcoulomb. That will be 4 microcoulomb. QB is 4x. 4 into 2 microcoulomb. It will be 8 microcoulomb. QC is equal to 5x. 5 into 2 microcoulomb. It will be 10 microcoulomb. That means the charge acquired by A, Q is 4 microcoulomb, B is 8 microcoulomb, and C is 10 microcoulomb. Numerical number 4. Can a neutral body acquire a charge of 5 into 10 to the power of minus 18 coulombs? Why and why not? This numerical can be answered on the basis of quantization of charge, which states that Q is equal to N into E. Q is the amount of charge which a body may or may not acquire. E is a charge on one electron, that is 1.6 into 10 to the power of minus 19 coulombs. And N is the number of electrons. Now, for the body to have a charge, N can be an integer, it may not be an integer. If N is an integer and N is not an integer, now if N is an integer, then the body will acquire a charge. Charge is possible. And if N is not an integer, then charge is not possible. In order to find out whether the charge which is given to us 5 in 10 to the power of minus 18 coulombs, is it possible or is it not possible, we'll have to find out the value for N. Now, according to the quantization of charge, N will become Q upon E. Q is a charge which the body is supposed to acquire. In this case, it is 5 into 10 to the power of minus 18 coulombs. We can put the value for charge 5 into 10 to the power of minus 18 upon the charge on one electron, that is 1.6 into 10 to the power of minus 19 coulombs. It will be 5 upon 1.6 into 10 to the power of minus 18 plus 19. If you solve it, it will be 5 into 10 upon 16 into 10 to the power of 1, because minus 18 plus 19 is 1. We can solve this. It will go on 5 to the 10, 8 to the 16, it will be 4, it will be 5. It will come out to be 5 into 5 into 5 is 125 upon 4. And if you solve 125 upon 4, it will be 31.25. Since N is 31.25, this N is not an integer. Since N is not an integer, a charge which was equal to 5 into 10 to the power of minus 18 coulombs is not possible. Why is it not possible? Because if a charge of 5 into 10 to the power of minus 18 coulombs, a positive charge of 5 into 10 to the power of minus 18 coulombs is to be given to that body, we have to remove so many electrons. That means 31.25 electrons are to be removed. We can remove either 31 electrons or we can remove 32 electrons. We cannot remove 31.25 electrons because electrons cannot be further subdivided according to our level. So we cannot say that the electrons, 1/4 of electron can also be removed. Therefore, this N should be an integer. Since N is not an integer, the charge of 5 into 10 to the power of minus 18 coulombs is not possible. Numerical number 5. electrons are removed from a given body at the rate of 2.5 into 10 to the power of 12 electrons per second. If the initial charge on the body was plus 3 microcoulomb, then what will be the final charge on the same body after 2 minutes? We can take up the case in this way. This is a body which was having an initial charge Q naught of plus 3 microcoulomb. And when you remove electrons from this body will again acquire more charge. And how many electrons are being removed? These electrons are being removed at the rate of 2.5 into 10 to the power of 12 electrons per second. And because of this removal of electron, the new charge the body will acquire is Q. Then the total final charge which is Q, and this Q will become equal to Q naught, the initial charge, plus the charge which the body will acquire after 2 minutes. We are given Q naught, which is 3 microcoulomb, and we have to find out the value for Q, which the charge the body will acquire after 2 minutes. Now, since it is given that the rate at which electrons are being removed from the body is 2.5 into 10 to the power of 12 electrons in 1 second, we can move forward with this. Now, dN upon dt, it is the rate of removal of electrons. Rate at which electrons are being removed from the body, which is equal to 2.5 into 10 to the power of 12, and it is given to us. dN is the number of electrons which are being removed in time dt. By cross multiplication, dN will become 2.5 into 10 to the power of 12 into dt. dN is the number of electrons which are being removed in time dt. If dt time which is given to us is 2 minutes, or we can say 2 into 60 seconds, it will be 120 seconds. In 120 seconds, how many electrons will be removed? We can find out dN here. It will be 2.5 into 10 to the power of 12 into 120. It will be 25 upon 10 into 120 into 10 to the power of 12. These are the number of electrons which are being removed. If you solve it, it will be 0, 0 will cancel. Now, 25 into 12, it is 300 into 10 to the power of 12 electrons. That means 300 into 10 to the power of 12 electrons are being removed in 2 minutes. Now, these number of electrons will be corresponding to how much charge? So, we can find out the value for charge. To find out the value for charge which is corresponding to so many electrons, we will use the concept of quantization of charge. Q is equal to N into E. N in this case is 300 into 10 to the power of 12 into E, 1.6 into 10 to the power of minus 19 coulombs. It will be 300 into 1.6 into 10 to the power of 12 minus 19 coulombs. It will be 300 into 16 upon 10 into 10 to the power of minus 7 coulombs. This 0, 0 will cancel. We will be getting 16 into 3 is 48 into 10 to the power of minus 7 coulombs, or we can say 48 in 10 to the power of minus 6 coulombs, 48 microcoulombs. This is the additional charge which the body will acquire after 2 minutes. Now if Q is representing total final charge, which is equal to Q naught, the initial charge, plus the charge which the body will acquire in 2 minutes. It will be equal to plus 3 microcoulombs plus 48 microcoulombs. If you add both, it will be plus 51 microcoulombs. The total final charge which the body will acquire after 2 minutes will be 51 microcoulombs. Numerical number 6. Two spherical conductors A and B of radius 2 mm and 6 mm having a charge of plus 5 microcoulomb and minus 9 microcoulomb respectively are brought in contact. Answer the following questions. What is the final charge on spherical conductor A? What is the final charge on spherical conductor B? What is the amount of charge transferred from which body to which body? How many electrons are transferred from which body to which body? We have got this numerical. There are two bodies A and B. A is a smaller body having a radius of 2 mm. B is comparative a bigger body having a radius of 6 mm. A is having an initial charge of plus 5 microcoulomb and B is having an initial charge of minus 9 microcoulomb. When the two bodies they are brought in contact, they'll have same electrostatic potential. When they are brought in contact, the electrostatic potential will become equal. When any two bodies have got same electrostatic potential and they are given some charges, the charges will be redistributed according to the radius. Now we will see to it how the charges are to be redistributed. The initial charge on the conductor A, body A, is plus 5 microcoulomb and the initial charge on the conductor B is minus 9 microcoulomb. We'll first of all find out that what will be the total charge which is to be redistributed. The total charge, that is Q, is equal to QA plus QB. The initial charge on the two bodies, it is equal to plus 5 microcoulomb plus minus 9 microcoulomb. 5 microcoulomb minus 9 microcoulomb. It will be minus 4 microcoulomb. The total charge which is to be redistributed among the two bodies, it is minus 9 microcoulomb. Now when this charge of minus 9 microcoulomb is to be redistributed, the charges are to be redistributed in such a way that the final charge will be depending upon their radius. More the radius, more will be the final charge. Less the radius, less will be the final charge. So the final charge on the conductor A, QA dash, and the final charge on conductor B, QB dash, will be depending upon the radius. RA is to RB. RA is what we have said earlier. It is 2 millimeters and RB is 6 millimeters. So we can put 2 millimeters is to 6 millimeters. And if you just take up the simple ratio, it will be 1:3. The ratio of the two new charges which the body will have will be in the ratio of 1:3. Here we can assume that let QA dash, the new charge on the conductor A, be 1x, because the charges are to be distributed in the ratio of 1:3. QB dash will be 3x, where x is any constant term. Now if the two charges are QA dash and QB dash, and QA dash is 1x and QB dash is 3x, but the total charge will remain same, sum of the two final charges will be equal to 4 microcoulomb. QA dash plus QB dash will be minus 4 microcoulomb. QA dash is, we had said 1x, and QB dash is 3x, will be equal to minus 4 microcoulomb. That means 4x will be minus 4 microcoulomb. Here 4 and 4 will cancel. What we will be getting is x is equal to minus 1 microcoulomb. Once you know the value for x, we can find out the final charge on the conductor A. QA dash is 1x. It will be 1 into minus 1 microcoulomb, that is minus 1 microcoulomb. And QB dash is 3x. 3 into minus 1 microcoulomb, it will be minus 3 microcoulomb. These are the final charges on the conductor A and on the conductor B. Now the charge is being transferred from which body to which body. The initial charge on the conductor A was plus 5 microcoulomb, and the final charge on conductor A is minus 1 microcoulomb. The initial charge on conductor B was minus 9 microcoulomb, and final charge on conductor B is minus 3 microcoulomb. Now it shows what? It shows that how much charge is being transferred from which body to which body. Here it was plus 5 microcoulomb earlier. Now the final charge is minus 1 microcoulomb. Now what will be the change in the charge on the conductor A? Final charge on the conductor A minus initial charge on the conductor A. Final charge on the conductor A is minus 1 microcoulomb, and initial charge is plus 5 microcoulomb. And if you solve it, it will be minus 1 microcoulomb minus 5 microcoulomb, it will be minus 6 microcoulomb. And how much charge is changed in conductor B? Final charge on conductor B minus initial charge on conductor B. Final charge on conductor B is minus 3 microcoulomb. Initial charge on conductor B is minus 9 microcoulomb. It will be minus 3 microcoulomb plus 9 microcoulomb. It will be plus 6 microcoulomb. That means 6 microcoulomb is added to the conductor B, and 6 microcoulomb is removed from the conductor B. That means 6 microcoulomb of charge is being conducted from A to B. Because 6 microcoulomb charge is decreased from conductor B, it means that 6 microcoulomb charge has been moved out of conductor B. And 6 microcoulomb charge is added to conductor B, means that 6 microcoulomb charge is being taken from the conductor A, it has been given to the conductor B. Now since from conductor A and conductor B, we have said that 6 microcoulomb charge is taken, plus 6 microcoulomb charge is taken from the conductor A to the conductor B. It means what? It means that electrons which are negatively charged will be going from conductor B to the conductor A. And how many electrons will be going from conductor B to the conductor A? We can find out these charges by using the concept of quantization of charge, which states that Q is equal to N into E. Q is 6 microcoulomb, 6 into 10 to the power of minus 6. And N is the number of electrons, and E is the electronic charge, the charge on one electron. From here we can find out N. N by cross multiplication is 6 into 10 to the power of minus 6 on 1.6 into 10 to the power of minus 19. And if you solve it, it will be 6 upon 1.6 into 10 to the power of minus 6 plus 19. It will be 60 upon 16 into 10 to the power of 13 electrons. And we can cut it here. 8 it will be 30, 4 it will be 15. It will be 15 upon 4 into 10 to the power of 13 electrons, number of electrons. 15 upon 4, it will be 3.75 into 10 to the power of 13. That means 3.75 into 10 to the power of 13 electrons will be going from the conductor B to the conductor A. Numerical number 7. Charge of plus 54 microcoulomb is to be distributed among 4 conducting spheres A, B, C and D of radius 2 cm, 3 cm, 4 cm and 5 cm in such a way that all the 4 spheres has equal surface charge density. What is the amount of charge given to each sphere? We can take up the case here. Here we have got 4 spheres A, B, C and D. A has got a radius of 2 cm, which is smallest among the 4 spheres. B has a radius of 3 cm, C has a radius of 4 cm and D is the largest among these 4 spheres. It has got a radius of 5 cm. Since they have said that the surface charge density will be same on all the 4 spheres, that means sigma is a constant term. Sigma, the charge per unit area, is constant. That means charge per unit area is sigma and it is constant. Charge will be equal to sigma into area. Here sigma is a constant term. We can take it up here. Since charge is sigma into area and this is what we had said, that sigma is a constant term and A is the area of each sphere. Since the area of the sphere is 4 pi r square, so we can put the value here. Q will be sigma into r 4 pi r square. Sigma and 4 pi are constant terms. Here charge will be depending upon square of the radius. Means that when you distribute the charges among the 4 spheres, the charge will be depending upon the square of the radius. Let the charge on the sphere A be QA and the charge on the sphere be QB and the charge on this sphere be QC and the charge on this sphere be QD. These charges will be in the same ratio as the square of their radius. RA square is to RB square is to RC square is to RD square. And the radius of the 4 spheres which are given to us, it will be 2 centimeters, 3 centimeters, 4 centimeters and 5 centimeters. So here we can put 2 square, 3 square, 4 square and 5 square. This will be the ratio of the 4 charges. It will be 4:9:16:25. This is the ratio of the 4 charges which will be given to the 4 spheres. Since the ratio is given to us, we can assume that let QA be equal to 4x and QB is equal to 9x and QC is 16x and QD is 25x. And here we can talk about x is any constant term. This is what we can assume. And it is given to us that the total charge should be equal to 54 microcoulomb. It means that the sum of the 4 charges will be equal to 54 microcoulomb. If you add up all the four charges, QA plus QB plus QC plus QD, the sum of the four charges will be 54 microcoulomb. So we can add the four charges, QA plus QB plus QC plus QD will be 54 microcoulomb. And we know that QA is 4x, QB is 9x, QC is 16x, and QD is 25x. Is 54 microcoulomb. Now 16 plus 4 is 20x, and 25 plus 9 is 34x. 54 microcoulomb. It will be 54x, will be 54 microcoulomb. From here we got x will be 1 microcoulomb. Since x is known to us, we can find out the individual charges. The charge on QA was equal to 4x. 4 into 1 microcoulomb, it will be 4 microcoulomb. The charge on B was 9x. 9 into 1 microcoulomb, it will be 9 microcoulomb. QC was equal to 16x. 16 into 1 microcoulomb, it will be 16 microcoulomb. And QD was 25x. 25 into 1 microcoulomb, that will be 25 microcoulomb. These are the four charges which are to be given to the four spheres so that the surface charge density on all the spheres will be equal. Numerical number 8. 270 grams of water is present in a cup. Take Avogadro's number as 6 into 10 to the power of 23. Answer the following questions. First, what is the number of moles in the cup of water? What is the number of electrons present in the cup of water? What is the total positive charge present in the cup of water? We can take up an example in which there is a cup of water which contains 270 grams of water. First of all, we'll see what is the chemical formula for water and how it works. Water has got chemical formula H2O. That means in one molecule of water there are two atoms of hydrogen and one atom of oxygen. We'll take up what will be the atomic mass of each. If it is two hydrogen atoms, the atomic mass of hydrogen atom is 1 gram. Since there are two atoms, it will be 1 gram plus 1 gram, it will be equal to 2 grams. And there is one oxygen atom. The atomic mass of oxygen atom is 16 grams. It means that the total molecular mass of H2O, water, is equal to 2 grams plus 16 grams. It will come out to be 18 grams. 18 grams is the molecular mass of water. If 18 grams is the molecular mass of water, it means that 18 grams of water will have 1 mole of molecules. And we can use a unitary method to find out the number of moles present in 270 grams. 1 gram of water will have 1 upon 18 moles of molecules, and 270 grams of water will have 1 upon 18 into 270 moles of molecules. Number of moles in 270 grams of water is equal to, it will be 1 upon 18 into 270. We can solve it. 9 into 2 is 18, 9 3s are 27, 8 to 2 will go to 15. That means there are 15 moles. That means in 270 grams of water there are 15 moles. Now we will be calculating the total number of molecules which are present in 270 grams of water. Now we know that in 1 mole of water molecules has got 1 Avogadro number of molecules. That means 6 into 10 to the power of 23 molecules. If in 1 mole we have got 6 into 10 to the power of 23 molecules, how many molecules will be present in 15 moles? In 15 moles of water molecules, there are 15 into 6 into 10 to the power of 23 molecules. That means we have got the total number of molecules. In 270 grams of water. The total number of molecules will be equal to 15 into 6 into 10 to the power 23. 15 into 6 will be 90 into 10 to the power of 23. That means 9 into 10 to the power of 24 molecules. That means in 270 grams of water, the number of molecules of water is 9 into 10 to the power of 24. Now we will be calculating the total number of electrons present in 270 grams of water. Before we would calculate the number of electrons, we will be calculating the number of electrons present in 1 molecule of water. 1 molecule of water which is H2O, it has got 2 atoms of hydrogen and 1 atom of oxygen. 2 hydrogen atoms and 1 oxygen atom. 1 hydrogen atom has got 1 electron, therefore 2 hydrogen atom will have 1 plus 1, 2 electrons. 1 electron plus 1 electron, that will be 2 electrons. And 1 oxygen atom has got 8 electrons. The total number of electrons in 1 molecule of water is equal to 2 electrons plus 8 electrons. 2 electrons plus 8 electrons, that will be equal to 10 electrons. In 1 molecule there are 10 electrons. And how many molecules do we have? We had already calculated that there are 9 into 10 to the power of 24 molecules. Total number of electrons is equal to number of molecules into 10, that will be giving you the number of electrons. Number of molecules is 9 into 10 to the power of 24 into 10e, and that will be equal to 9 into 10 to the power of 25 electrons. The total number of electrons which are present in 270 grams of water is 9 into 10 to the power of 25. Now we can calculate the total positive charge which is present in 270 grams of water. Before we could calculate the total positive charge, one thing should be clear, that the total negative charge is equal to the total positive charge in case of water. The total negative charge is due to electrons and the total positive charge is due to protons. The number of protons is equal to the number of electrons. In order to calculate the total positive charge, we will be calculating is equal to the number of protons into the charge on one proton, which is 1.6 into 10 to the power of minus 90 coulombs. The total number of protons is equal to the total number of electrons. We had already done the total number of electrons is 9 into 10 to the power of 25. The same will be the number of protons. It will be 9 into 10 to the power of 25 into 1.6 into 10 to the power of minus 19 coulombs. It will be 9 into 1.6 into 10 to the power of 25 minus 19 coulombs. We can solve it in this way: 9 into 16 upon 10 into 10 to the power of 6 coulombs. 9 into 16 is 144 upon 10 into 10 to the power of 6 coulombs. It will be 14.4 megacoulombs. The total charge which is present on total positive charge which is present in 270 grams of water, which is also equal to the total negative charge, it is equal to 14.4 megacoulombs. Numerical number 9. Charge is uniformly distributed along x-axis and the linear charge density is 8 microcoulomb per centimeter. There is an imaginary circle of radius 3 centimeters and center at the point 50. What is the total charge included in this imaginary circle? Now, before we could move forward, we can just see what is there in this question. There is a charge which is uniformly distributed along x-axis such that the linear charge density lambda is equal to 8 microcoulomb per centimeter. And there is an imaginary circle of center at the point 50. This circle has got a radius of 3 centimeters. It means that the length of the x-axis which is included in this circle is starting from x equal to 2 to x equal to 8. x1 equal to 2 centimeters to x2 is equal to 8 centimeters. So we have to find out that what will be the charge which is included in this circle. We can start with the linear charge density lambda. Charge per unit length dx is lambda, and which is 8 microcoulomb per centimeter. dq by cross multiplication will be lambda into dx. In order to find out the total charge, we will have to integrate this expression within the suitable limits. The total charge dq will become equal to lambda into dx from x1 to x2. And x1 is, we have said 2 centimeters, and x2 we have said it is 8 centimeters. From 2 centimeters to 8 centimeters we have to find out the total charge. So we can put the values here. From 2 centimeters to 8 centimeters, lambda is 8 dx. The total charge whatever we'll be getting will be in microcoulombs. Here 8 can be taken outside, integration of dx from 2 to 8. 8 integration of dx is x from 2 to 8, and if you solve it, it will be 8 into 8 minus 2, and 8 minus 2 is 6. Now 8 into 6 is 48. The total charge which is included will be 48 microcoulombs. Numerical number 10. Charge is uniformly distributed throughout the volume of a sphere of radius r. If the charge present per unit volume of the sphere is rho is 14 r microcoulomb per centimeter cube, then what is the amount of charge present in a sphere of radius 2 centimeters? Now, according to this numerical, there is a charge distribution where rho, the charge present per unit volume, is equal to 14 r microcoulomb per centimeter cube. And we want to find out that what will be the charge present in this distribution in a sphere of radius 2 centimeters. That means we are supposed to find out the charge present in this spherical region whose radius is 2 centimeters. Now we can move forward with the charge distribution. If we have got rho, charge per unit volume, and rho is equal to 14 r microcoulomb per centimeter cube, dq by cross multiplication will become rho into dv, and rho is 14 r into dv. This is the required equation which we are supposed to integrate. But before we could integrate, we have to change dv in terms of r. dv is a volume, and volume of a sphere is equal to 4 upon 3 pi r cube. And if you differentiate this equation with respect to radius on both the sides, we will be getting d upon dr of v and d upon dr of 4 upon 3 pi r cube. Here we will be getting dv upon dr, 4 upon 3 pi, we can take it outside, d upon dr of r cube, and we can solve it further, dv upon dr, 4 upon 3 pi, differentiation of r cube with respect to r is 3r square. Here 3 and 3 will cancel. What we will be getting is dv upon dr is 4 pi r square. We can write down this way also, dv is equal to 4 pi r square dr. This is the required equation of dv in terms of dr. What we can do, we can put the value for dv here. If you put the value for dv in the previous equation, how much you will be getting? dq will become equal to 14r, which is the value for rho, into dv. dv is 4 pi r square dr. Whatever equation we will be getting here, this equation, this is the required equation which we are supposed to integrate to calculate the total result. We can make it more simple. dq will become equal to 14 into 4 pi r cube dr. Now we will have to integrate this within the suitable limits. The suitable limits are from 0 to 2 centimeters, we have to find out the total charge. So in order to find out the total charge, we can see to it dq will become equal to 14 into 4 pi r cube dr. If you find out the total charge, it will be 14 into 4 pi r cube dr from 0 to 2 centimeters. Whatever charge we will be getting, this charge will be in microcoulombs. 14 into 4 pi, we can take it outside, integration of r cube dr from 0 to 2. 14 into 4 pi, integration of r cube is r to the power of 4 upon 4 from 0 to 2. This 4 can be taken outside. 14 into 4 pi upon 4 into r to the power of 4. Now we can write on 2 to the power of 4 minus 0 to the power of 4. From this expression, we can cut this 4 and 4 will cancel. We will be getting 14 pi into 2 to the power of 4 is 16 minus 0. The total charge, what we will be getting here, is equal to Q is equal to 14 pi into 16. We can put the value for pi 14 into 22.7 into 16. Now this 7 will go on to 7 to the 14. We can have the same expression here, 2 into 22 into 16. It will be 44 into 16 is 704 microcoulomb. Numerical number 11. Charge is distributed along x-axis and the value for linear charge density is 4x microcoulomb per centimeter. If a circle of radius 5 centimeters is drawn with center at 5,3, then what is the amount of charge included in this circle? We can take up this numerical in this way. Let there be x-axis on which charge is uniformly distributed and the linear charge distribution is 4x microcoulomb per centimeter. We can imagine a circle whose center is at the point 5,3 and the radius is 5 centimeters. The center is at the point O, whose coordinates are 5,3. Now if you draw a perpendicular from the point O, which is the center of the circle, on x-axis, the length of the perpendicular will be equal to 3 centimeters and this point will correspond to 5 centimeters. Because the coordinates of the point O are 5,3, because if you draw a perpendicular, it will meet x-axis at the point 5 centimeters and the length of this perpendicular will be 3 centimeters. And we are also given that the radius of the circle is 5 centimeters. It means that if you join the point O to the circumference, it will be 5 centimeters. And if you take up this whole triangle, which is a right angle triangle, in this right angle triangle, hypotenuse is 5 and perpendicular is 3. We can find out the base. Perpendicular square plus base square is hypotenuse square, and if you use this concept, the base will become equal to 4 centimeters. Once you know the base as 4 centimeters, this point is corresponding to 5 centimeters and this distance is 4 centimeters. It means that this point will correspond to 1 centimeter. 5 minus 4, it will be 1 centimeter. Now this distance will be also 4 centimeters and this point will correspond to 5 plus 4, that is 9 centimeters. It means that the circle will cut x-axis at 2 points, at one point 1 centimeter and at the other point 9 centimeters. It means that the first point at which the circle will cut x-axis will be x1 is equal to 1 centimeter, and the second point at which it will cut x-axis x2 will be 9 centimeters. Now we can redraw this whole thing in this way. This is the point O. The length of the perpendicular is 3 centimeters. The coordinates of this point where the perpendicular will fall on x-axis will be 5, 0. 4 centimeters, it will be coordinates will be 1, 0, and again this will be 4 centimeters and the coordinates of the other point will be 9, 0. Here this point will correspond to x1 equal to 1 centimeter and this point will correspond to x2 equal to 9 centimeters. That means we are supposed to find out the charge in between 1 centimeter to 9 centimeters. Lambda is given to us. Charge per unit length dx is equal to lambda and dq will be lambda into dx. Here lambda is given to us as 4x microcoulomb per centimeter. We can find out the total charge by integrating lambda into dx from 1 to 9. That is the point where x-axis will be met by the circle is 1 centimeter to 9 centimeters. We can put the value for lambda 4x dx from x equal to 1 to x equal to 9. 4 is a constant term, we can take it outside. Integration of x dx from 1 to 9, and 4 is already outside. Integration of x dx is x square upon 2 from 1 to 9, and we can write on 4 upon 2 x square from 1 to 9. That will be q. We can take it up here. Q will become equal to 4 upon 2 x square from 1 to 9. 4 upon 2 is 2. It will be 9 square minus 1 square. It will be 2 into 9 square is 81 minus 1. 2 into 80. That will be 160 microcoulomb. Numerical number 12. A charge of 198 microcoulomb is to be given to a conducting sphere of radius 3 centimeters. What is the surface charge density of the conducting sphere? The surface charge density sigma is defined as charge per unit area. Area of a sphere is 4 pi r square, so it will be q upon 4 pi r square. In this expression we have got different values. Q is 198 microcoulombs and radius is 3 centimeters. We can keep the charge in microcoulombs only and we can keep the radius in centimeters only. If you substitute the values, we will be getting 198 microcoulombs upon 4 into 22 upon 7 into 3 square. That will be microcoulomb per centimeter square. The units will be microcoulomb per centimeter square. We can put the values here. Sigma is equal to 198 upon 4 into 22. 7 can be taken up into 9. It will be microcoulomb per centimeter square. If you solve this, we will be getting 11 into 2 is 22, 11 1s are 11, 11 8s are 88. And 9 into 2 is 18, will cancel. The things which will be left is sigma is equal to 7 upon 4 microcoulomb per centimeter square. It will be 1.75. microcoulomb per centimeter square. Numerical number 13. Two conducting spheres 1 and 2 have same surface charge densities. If the radius and charge on sphere 1 are R1 equal to 5 centimeters and Q1 equal to 50 microcoulomb respectively, then what is the amount of charge on sphere 2 whose radius is R2 equal to 2 centimeters? Here we have got two spheres 1 and sphere 2. Sphere 1 has a radius of 5 centimeters and a charge of 50 microcoulomb. Sphere 2 has a radius of 2 centimeters and charge we are supposed to find out. But it is given that the two spheres has got same surface charge density. If the surface charge density of 1 is sigma 1 and the surface charge density of sphere 2 is sigma 2, it is given that sigma 1 is equal to sigma 2 and the surface charge density on the two spheres is same, or we can just that sigma is constant term. Now when sigma is a constant term, sigma is charge per unit area is constant. By cross multiplication, charge will be sigma into area, and area of a sphere is 4 pi r square. Now in this expression, sigma is constant and 4 pi is also constant. Q will be depending upon square of the radius. That means more the radius, more will be the charge, less the radius, less will be the charge. Now we have got two spheres, the charges will be in the ratio of Q1 is to Q2, and that is R1 square is to R2 square. It is given that R1 is 5 centimeters and R2 is 2 centimeters. Here we can put 5 square and here we can put 2 square. It will be 25 is to 4. The ratio of Q1 is to Q2 is 25 is to 4. We can say let Q1 is equal to 25x and Q2 is equal to 4x, where x is any constant term. Now it is given that the charge on the sphere 1 is 50 microcoulomb. That is Q1, which is 25x, it is 50 microcoulomb. Q1, which is 25x, it is equal to 50 microcoulomb. From here x will be 50 upon 25 microcoulomb, or it will be 2 microcoulomb. Now if x is 2 microcoulomb, Q2, which we have here, it is 4x. So we can put the value for Q2, 4 into x, 4 into 2 microcoulomb, it will be 8 microcoulomb. That is the charge on the sphere 2 should be 8 microcoulomb.